Hello everyone, in this video we are trying to follow this book Cloud-Based Remote Sensing with Google Earth Engine chapter A1.8 Monitoring Gold Mining Activity using SAR. This chapter is about the change detection using Sentinel-1 SAR data. So we have two different data formats for Sentinel-1. The first one is the logarithmic scale and the other one is the float format. So in this chapter the float format is being used. So we usually see this Sentinel-1_GRD data while we search the Earth Engine data catalog, but this chapter uses this second one, underscore followed by float. But overall the ideas are same for each of these data, just the conversion from one type of values to the other. So the Sentinel-1 SAR data present on the Earth Engine has gone through several processes or several steps. So we have the orbit metadata update, removal of board and thermal noise, radiometric calibration and terrain correction. So the Sentinel-1 datasets are not easy to interpret like the optical images, so it is quite different compared to the others. So we're trying to quickly go through the chapter, but there certainly remains many things to learn, and it is not easy as compared to the previous chapter A1.7. So we will quickly go through the codes. So here is the first section. I have already run this one. So it begins with defining the area of the study. This is the string where the feature collection is. Then we are centering and zooming it at the level 9, and after that we are creating an empty image. So this is just to visualize the feature collection, so the colors and white is given to the feature collection. Then we have the map.set option satellite, so this selects the satellite option in the map layer. Then we are adding this feature collection or our area of study to the map layers, and the color is red, and the name of that layer is area of study. And here is the function. So we will select the image, and from that image we are selecting the angle. So the Sentinel-1 dataset comes with the different polarization and also with the angle. So in this case we want to have the angle greater than or equal to 31 and less than or equal to 45. And here we see the way to use the operators in Earth Engine. So we are using .gte and followed by .end, again followed by .lte with the values at the end, and this will return the images that will have the angles greater than 31 and less than 45. Then we have another function here. So here the dates will be checked, our study of area will also be checked, and our orbit passes will also be checked. So you can see here the typical data is underscore float, and this is not usually seen in the Earth Engine data catalog, and this is the reason why the conversion to the other scale has been done in this process. And this dataset is followed by .filter bounds, just to make sure that all the images are within our study area. Then we are doing this .filter date. We have the dates, the first date and the second date, that they will be provided while we use this function. Then we will have this .filter, and this is the orbit properties pass. This comes from the image metadata, and then we have this orbit pass as the parameter in this function, and we will return this image collection where we have this angle greater than or equal 31 to 45, and we will select these two different polarization. So very nice function here, so we can use this function in our case as well. Then here we are providing the list of dates. So the first one is the 2021 month 8 and the first day of this month, and the other date is here. And our orbit path is descending, so the Sentinel one has the ascending and descending as the orbit path, and usually these are not mixed because it depends on what we're doing, but these are not usually mixed. And here we are providing we are using this function get collection, and for that we are providing our dates, and then followed by the study area, and then the orbit path that is descending. And this is followed by dot mosaic, and this dot mosaic joins the images present on that area. So there might be some different tiles, so the images from different tiles, or all the images are just joined as the new image. So this is very different than using dot mean and dot median. And that mosaic image is clipped by our study area, and then we print them here. So this is resulting in two different bands. So this is giving us the single image. And then here we are doing this logarithmic scale application. So we are scaling the values to the logarithmic scale. So there is dot log 10 followed by dot multiply, multiplying with constant 10. And then we can visualize the results. So we will have the three different bands in different RGB, and then we have the minimum and maximum values. So here these big brackets are being used. So each values are for each different bands. And then we can add this as the layer, and we see something like this here. So the first one is our area of study, and the second layer is the Sentinel one SAR mosaic. And if we see here in the console, we see the two images. So here the values are in the float, and here we can see the values now being changed into table. And if we click on the inspector and check different values, we can see the different values in VV and VH. So this is the first section. We defined our area of study, and we tried checking the images with the angle greater than or equal to 31 to less than or equal to 45. Then we filtered the Sentinel one GRD_float data by two different dates with the orbit path as descending. And after that we mosaiced the image, we clipped for our region, and then we did this logarithmic scale, and then we visualized the result. So this is the first section. Then we move to section 2. The section 2 is similar to what section 1 does. So this is just making the base for the chapters. So in the chapter, if we check this, they have explained other things, but this is just a repetition of the section 1. But in this case, the new thing is just they have printed, or we can see the image collections being printed, and we see 30 different images. So these are the images from 2021 or the whole year for the year 2021. And then we check the third section within this section 2, and here we see this function get dates. So this is the function where the dates are being formatted into the year, month and date format. So here this dot format is changing the date into this format, and here we see the ee.date. So our engine will understand that this is the date, and this will be formatted in different way. Then there is this next function. So here this is the function mosaic SAR dates 1. So here this function will take the dates, and then we will make sure that it understands this is the date, and after that for the image collection we are filtering it with that date, the first date, and this will be advanced with 1 day ahead, and the image that is present within that single day will be mosaiced, then clipped, and then the time properties and the dates will be added to that image. So basically we are filtering the images within a day, mosaicing it, clipping it, and providing it with the new properties. So this is the function here for that one, and then we will get the SAR image collection of the mosaics by date. So just to check those images, just to get the dates here, we are aggregating our array, meaning just checking the time step properties, and dot map get dates will give us that dates, and this will just make sure that each unique dates are being chosen. And then we see this dates mosaic is mapped with the mosaic SAR. This is the other function to get the images, and this is being converted into the image collection, and then we have printed this, and this gives us something like this here, the image collection with we have 30 elements, each with the 2 bands, and then we see the visualization again. Then we see these images being filtered, and that filter image we are selecting the first one, then applying this logarithmic scale, and this is being repeated for the second image, and this is for, and these two are for different dates. The first one is for other date, and the second one is for the around the end of the year, and both of these images are added as the layer. So we can see here, this is the area of study, this is the Sentinel-1 image for the first month, and this is the Sentinel-1 image for the last month. So the 2 different images are there. We did all this process to get these 2 different images. So in this section we formatted the date, we tried to get the image within a day, mosaiced it and clipped and provided it with some properties. Then we wanted to get the SAR collection of the mosaiced image, so we mosaiced those images and we checked those mosaic images by the date, selecting the very first image from the very first month and the second image from the last month, and we added them as the layer. And the book talks about this this methodology where the change detection is being done. So explaining them or trying to go through them will be the next thing to do, but what's being done here is the already written codes are being loaded here, and this methodology provides us with the 4 different results. So basically the 4 different these values are the ways to know how the changes has taken place. For example, the CMAP tells us the interval in which the most recent significant changes have occurred, and similarly other are also related with some changes. And here the function is being applied. We see it here with providing the images. Some significant values are being provided, and this median has been set as true. And we see the result something like this here. So we see the different images. So these different images means the different types of changes. And here we see this feature collection being built from the dates. So here is the feature collection, and that feature collection we are mapping this, and the result is to get the dates, and after that we are getting the visualizing parameters here, and all these images are being added as the new layer. We are exporting the feature collection with the dates of ranges, just exporting the feature collection and also exporting the images. So what we're seeing here is the first one is the area of study, 2 different images from 2 different months. So the first one is the recent changes. So these are 2 different images that are resulted by that function. And well, it's taking time here, but we can check that one, what it does. And the images, or that particular image, change detected image, is exported and again imported here. So the chapter does all these things for us, and what now follows is that not all the changes are due to the auth mining things. Well, the whole chapter, I didn't talk about this, but the whole chapter is about the detection of that auth mining activities occurring place in this area. So not all the changes might happen due to the mining activities, because there might be other things going on, such as plotting or maybe such environmental occurrences resulting in some kind of changes. So for that reason, all the datasets are used to to filter those changes, just to be sure that the changes are just due to the mining activities. So here the first layer is this one, change map unfiltered, and then here we are importing the SRTM, doing the slope, and all these datasets are being used, and all these datasets have different ways to interpret different things for analysis, but the important one is here. So in that change detect image, which we are seeing right now, is being masked with different properties, and we are just masking all those values from other data sets. And we see, so this is the change map unfiltered. Then we had this SRTM, slope, forest cover, whatever it is, and this is the one with the change map filtered. And here is some function to filter the small patches and isolated pixels, meaning just to ignore some minor changes. For example, here the values should be greater than 0 for this first parameter. Then the images in the second parameter should be divided with some with the function here to get the count of those pixels, minimum pixels. And the first parameter is masked with this one, with the values greater than or equal to some minimum pixel count. So basically the function is using trying to filter out the probability changes that are occurring there. And what we see here is this one, and the images are exported. Well, this is the chapter here. I tried to go through this chapter, but there remains so many things. For example, in this section alone, there are the examples of using different data sets to make sure the changes are happening through the exact region for what we are searching. And this can be a valuable way to apply in our case as well to change detection analysis. Well, I tried to go through them, but I sure might have missed so many things. As I said at the very beginning, this is not easy as compared to the previous chapter, because this includes the Sentinel-1 dataset. Sentinel-1 dataset is itself a very different type of dataset, not exactly easier to interpret like other optical images. Well, I believe this was helpful to you at some extent. If this was, and if you're watching till the end, thank you for watching. If you have any comments, you can comment them out. We will surely discuss them. So thank you for watching.